All right, the goal for this recording is just to create a simple log that I can use in the future to reference the stages of this project as I am going through it. I'm going to try to explain some of what I'm doing in a way that's clear, but a lot of this might get repackaged into a clearer video later on the main channel. This is just unscripted and off the cuff. So to introduce this, today is February 2nd of 2025. I've been working on this project since the beginning of December last year. And I've got about 4,000 lines of code so far in this project. It started off as this file. It's based on my main code base, and yeah, it's got a couple of main modes that I've been running it in. So it's kind of multiple programs packed together, multiple different tools that I can use. It's essentially a simulator for an RPG game in a way. I guess is the simplest way to describe what it does. I can, well, if I set this up so it can actually run Visual Studio, I can run it in the one of its modes, the currently active mode the one that I use the most, to run a bunch of samples of a sort of AI programmed, and by AI I don't mean machine learning, I mean like a simple little scripted bot to run through the game and measure how well it performs. And that's what this graph here is showing, various different ways to configure a challenge and the sort of player details here and how well the bot fares after 10,000 samples or something like that. It gets graphed here. And maybe in future parts of the log, I will detail more specifically what this graph is and all the rules of the simulation. But I just wanted to show you basically what I've been working on. The next steps here for working on this project, at least the parts that are on the channel, are there's two main branches here. There's architecture and design process stuff that I want to talk about. So I have, I've spent 1 month just slapping together a prototype with a bunch of cool features that I like. And I haven't done a whole lot to clean up the code as I go, except for what it's necessary to keep making progress on the prototype and refactoring to add new features and so on. But at a certain point, I'm starting to reach a critical mass where there's a lot of code that I have dashed through quickly, and I know that if I were to do a pass on understanding what the core mechanisms and features look like and the information transformations that are relevant, and pull those out and organize them and then put them back down into code, the thing that comes out of that process would be a lot more simplified and streamlined. It might also be a little less flexible if I'm not careful. So I want to include a second constraint, which is a bunch of unfinished experiments in the sort of game design side. There's more things I'd like to add to the simulation of the game that I don't have yet. So to show you how that part works, right now, when I quote unquote script things for the game, it's still in C, and I'm using a bunch of interesting techniques. So there's the second part here, which is the sort of scripting techniques that I've been developing over the last month to go with this project. And so I can script like these components that are called tiles. I don't know if component's the right word. It's going to summon the idea of an entity component system, which is not what I mean to do. It's just one of the poles of my design is the tile. There's also another pole, quote unquote, called a character or brain. There's a mismatch. There's some disagreement on what the naming scheme is here. There's scripting techniques for specifying data structures, like simple little data structures, like this little script here that I've got for specifying a prototype character. There's also, if I go over to the sim file here and look at the way I specify these things called roads, which are part of the model of the game, there's like, this scripting system which I've discovered that I can get quite a lot of mileage out of this. I made this little scripting system for describing a series of these RPG encounters, and then I can use formatted strings to generate a bunch of different combinations or variations or gradients or whatever between different like ways of configuring the road, right? So I want to go through and describe what I've done there and improve upon those designs even further. This is things like the run before main scripting. There's also the data structure scripting stuff. And then there are a few other things here that were of value that I want to make sure to keep in the ongoing. So they've got a lot of to-dos, right? If we get back to like here at the bottom, I've got a list of some things I'd like to be able to do that I can't do or need to be able to do better. And so there are some design problems here. Designing the runtime and composition rules, systems or whatever for scripting. So this is the project I've been working on, and I intend to make a few little videos here and probably paste them all together, going over these things, and maybe I'll introduce the project as well, like what features it has through this part, and then talk a little bit more about this. You know, these are the arrow diagrams, the API simplifications, and organizations. There's also later on I need to think about like how the runtime modularity of this is going to work. How are the identifiers going to work? What I mean by identifier, I mean these things that I'm using as strings right now. There might be a limit to how far I can actually push scripting things that way. Something like that. What else have I been up to that I want? Oh, so there's a third prong here, which is the data display through ASCII. All right, so I want to be able to, I've got a histogram and mini histogram printing system. I want to clean up and package as a library together with table printing, and I also want to make like a pluggable printf in my base layer. So there's some stuff to work on that has sprung out of this project. So there we go. All right, so to summarize, I know this is probably a weird, chaotic introduction to what I've been doing, but I have just finished coming out of this prototyping phase. I've got a big, interesting mess on my hands. I haven't really shown you everything it can do and why I'm interested in continuing with it yet, but as well as me having fun with this for the next few months is what I've got all these sort of interesting side projects that are spinning out of it in terms of tooling and opportunities for furthering, like describing these scripting techniques and improving upon them even further, and also opportunities for showing more of my architecture process, which I'm still trying to figure out how to show to people. In 2024, I did a couple talks on them. I got some feedback on what was making sense there, and I think that what I need to do is spend a lot more time showing a drawn out version of my process, and not just showing it, but capturing it raw, like what I'm doing right here in this video. So no live audience, just me doing what I do. And I'm going to try to catch myself doing it so I can see more about how it works in these videos. Okay, I'm going to go through these different modes real quick and show what they are and what they look like and a little bit about how they're implemented as well. So I'm going to start with the log mode. I'm going to run the simulation in log mode, and let's see, I'm going to put... I'll do it like this. We can see the snake in action and the adventure party. Okay, cool. Okay. So I run the program in build mode or in log mode, and in log mode, the code here, all it's doing is setting up the party that's going to run. The log mode does one run. It's not doing lots of samples like the other modes do. Instead, it's just doing one run and then creating this log. And so this is useful for debugging to see if things are behaving as expected. There's some notation here, so you know there's a versus line. The lines above are your party, and the lines below are the the creatures in the encounter that's being simulated. And the rules of the game I'll skip over for now, but they go through a series of rounds where each side takes some damage, and they might be able to use some of these. So here we can see before encounter 1 even begins, this character has, so I'll explain what these pieces over here are. This is HP, right? Total out of max. This is a sequence of tiles. So each of these is called a tile, and this is how I print them as this dollar parenthesis thing right now when I'm logging them. It's also how I note them in places like this. I can do, my scripting system uses this $sign notation as well. And so then I can see things like, okay, this one has been used. That's what the tildes here mean. This one has been used. So this is a once per day tile. That character's bot used it on itself. And we can also see this character here with the taunt took damage and has 1 out of 99 poison. So this particular tile has a counter on it. Right now, not all tiles have stacks, but this one can be stacked. So it shows the stack there as a multiplier. And oh, it looks like this character ended up with getting hit twice and taking 2 poison. Now we also spawned the team with antidotes, so 3 of our characters have an antidote. The medic doesn't have an antidote because they have a first aid kit, so they don't benefit from a 4th antidote, but these 3 characters can carry an antidote. And then hopefully, let's see, encounter 3, yeah, someone else gets hit. Now when they go to camp, they must have used those antidotes because they're gone now. So they removed poison from this character and this character, I assume, because they both healed 1. So the rules are when the party camps, each character heals 1, and then poison gets applied. So if they hadn't used the antidotes, this guy would have died, and this guy would still be at 2. So yeah, this is the log mode. Hopefully that gives you an idea of what it's for and how it works. It lets me inspect these things interacting, and as I change what pieces are in the simulation or what bots are running through it, I can make sure they're behaving correctly. All right, next I want to show the run mode. So the run mode is actually the oldest mode in the code base, and it's a little less developed at feeling than the rest of the modes, I think. And that's because this is sort of where the project started. There was one other mode, the very initial sort of just printing to the screen, that was not through the current log mode system, but that all got rewritten. So this is one of the oldest things that hasn't been rewritten. And it looks like this. And the idea here is in run mode, it simulates 1 run. There are 2 sort of sub modes. It can either measure the number of rounds that the party survives or the number of KOs that occurred in a single round. So then the simulation only has to run 1 round per sample, whereas here it's running however many rounds it takes for the party to get wiped out. And so we can see a little histogram comes out here, and it's all rendered out in ASCII. This histogram rendering has some issues, and so one of the things I should probably do is a pass over the histogram rendering to make it a little more robust. Right now, it's not doing anything inaccurate, although this might also be better if there were some labels and stuff. It's got min and max here, so this is this three. This column shows sort of how often we had a party survive for 3 rounds, and survive means that they died on round 3, right? So the party gets wiped out on round 3. So they survived round 1, they survived round 2, and they died on round 3. And 4 rounds, 5 rounds, 6 rounds, 7 rounds, 8 rounds, 9 rounds, and 10 rounds. So if I look down here at the code for run mode, it sets up a party, sets up the items you want them to have. Again, we give them 4 antidotes, but the medic will take a first aid kit instead. And then the road that they're going to walk across has a number of encounters. If there were different types of encounters, they'd be shuffled, but with all of them being the same, the shuffling doesn't do anything. And then we run the simulation, and we run it multiple times to create, a distribution here. And inside that function RPG run, all of the logic of the simulation actually happens. That repeats a certain number of rounds. And you can see here we have these, if the player party has no children, the children would be the party members. So if the number of party members has gone to 0, the size of the party has gone to 0, something like that, right? Then you jump to outside of the loop. And when we're done, we are returning the number of rounds that we got to, right? So that's the run mode. With this mode, there's a lot of work I could do. I think it is useful. It's kind of... how do I want to put this? Misleading to measure the difficulty or the danger of a particular encounter or a cluster of encounters that make up a road by looking at these histograms, though, because after I studied it for a while, it started to dawn on me that there's going to be a lot of variance in the number of rounds you can do the same road over and over again. But basically what happens is the first round that you start, someone gets knocked out, you're usually either going to die, the whole party's going to get wiped that round, or they'll get wiped the next round. There's the likelihood of losing a party member is kind of what really counts. Now, there are exceptions. It's possible for a party to make it a little longer against some roads than others with a reduced party size. But anyways, this is part of what I was studying at this point in the project, and so I have this histogram renderer, and I'd love to upgrade the histogram renderer and maybe upgrade the run mode to be able to measure more types of things and display them more cleanly and stuff like that. Okay, so the next mode I want to show you is the Analyze Roads mode. This was where the project went from being just a fun little exercise to digging in and doing some pretty exciting stuff that I'm having a lot of fun digging into. So, okay, so here it is. So what you're looking at here is a sort of a table. There's, columns and rows. It's pretty bare bones. So these are empty cells in the table that didn't get eliminated out. But there could be, the items would go here if there were items, and special rule changes would go here if there were any. But in this case, the run, we're just testing. We set up a party. The party can be made up of different combination of characters. And then we've got a road. And each of these is a road. And a road is a combination of, well, it's scripted out in this way. And I haven't really explained how that works yet. But each of these is a sort of scripted notation for a quote-unquote road, a sequence of encounters. And all of these have 6 encounters. I'm just shuffling the number around. And what's happened is I've run each combination 10,000 times, right? I've taken this n samples of each of these combinations and made a histogram of the number of KOs or the number of party members that got killed or knocked out or whatever in one round of that road. Okay, so I'm running it 10,000 times, but it's always a fresh party at the beginning of one round, and then I measure KOs and I graph them like this. And you can see it's not just a line because it's sampled. So there's a mean of 2.27, but sometimes there's a really high variance, it wiggles a lot. Sometimes there's a lower variance, like it's here and it's pretty reliably there, it doesn't wiggle a whole lot. So it doesn't just graph the mean, it's graphing the variance as well. And then what's happened is it's sorted them. So the order it chose here is not the order they were originally, put in, but it sorted them according to the first column, which is this farmer party. And so we can look at how this looks when it's sorted and compare it to, it does look like it gets a little more difficult for the mercenary party and the adventure party as well on those higher end ones, but the adventure party is the best at surviving with minimal casualties, but it starts to get pretty hard for them too. The mercenaries do really well at first, but they fall off with any amount of difficulty. And this is really cool to see because it's sort of like as I'm tweaking and tuning up different types of characters in the simulation and seeing how they behave and how they fit in, having things like a mercenary party that is very predictable in how it behaves, low variance, and really good at the easiest stuff, but falls off on higher difficulties, and compare that visually. This graphing has been really interesting to look at this whole time. There are some cheap things within the code for how this works. These quote-unquote histograms aren't actually being rendered correctly as histograms. I sort of just cheated and did assumed it was a normal distribution, gave it like a box and wires kind of algorithm to fill out based on the mean and the size of the standard deviation. But I'd love to go and build like a more full version of this ASCII rendering for a tight histogram that can be packed into a table like this that is truly a histogram. On top of that, let's take a quick look at how the Analyze Roads mode gets coded up. There's this series of road tests. A road test is basically everything that goes into a simulation besides the road. So what's the party, how many days? I think that's actually not relevant now that I think about it. That might be, well, we're going to ignore that for now. That might, wait, no, that's relevant. That's relevant. Sorry, I remember what that is now. A round includes a certain number of times where you can camp, and how many times you get to camp is determined by how many days that you have to cross the road. And so then what happens here, and this is the part that's really cool, is those little scripts, as I call them, for describing each road are actually just there's just like one-liner expressions that I can generate using a push F, a formatted string linked list here. So I'm just able to accumulate up a separate string for each one, and I'm sort of iterating over all the combinations for N1, N2, and N3 that add up to 6. And so I get my list of strings, and each test then it parses a road using this RPG road from script function. It can take in a string called the script, and it creates one of these proto road types that it can actually run through the simulation. So that's how all that stuff works. So a glimpse at how that stuff works, at least. Not all of it, but that's a glimpse at how all this is working. And that's it for that one. Okay, this is the last mode that I have, the symmetry test mode. I already ran it, so I can show you the results without having to wait for it. It looks like this. It's a matrix, so it's not just a table, but it's a table where the rows and columns, right? Farmer, mercenary, adventure party, and the other adventure party, and same stuff here, right? So it's a table where we're running a party against another party, and we're looking at the results as two different means, right? The mean number of KOs or kills or whatever in this party, and then comma, and then the number of KOs in this party. And since they fight, the encounter goes until one party is out of characters right now. There's no giving up or anything. There's no other end. One of these is always pretty close to 4. They're always like 3 point something. And there's some interesting stuff in here looking at just this. The reason I originally wrote this was to make sure, as I was building the engine and transitioning away from the first couple of days where I didn't have a symmetric system, to what I ultimately decided to do, where the entities and special moves and properties that were applied to creatures were all going to go through the same core engine as what went through for the player, and that the creatures would just be sort of simple brain bots, not like, I don't know how to describe that exactly. Maybe we'll talk about brains another time, and I'll make that clearer what that thought process was. But they're supposed to be symmetrical during combat, so I wanted to actually put all of the put that to a test by making these tables here, and then I can see, like, okay, yeah, so that party does really well against the farmer party. It only tends to lose one member. And if we look over here, flipped around, it's the same thing, right? That number, that number, that number, that number. So it all looks like the engine is now symmetric. There was a time when I first wrote it that the engine wasn't perfectly symmetrical, and so I was just making sure I had found all the cases where one party was referenced in a special way that the other party wasn't. But now that I have it, it's also a cool tool. It reveals some cool stuff about different parties. One cool metric it gives is this party versus self thing. So when I'm counting the number of KOs that happen when these parties go against each other, this much variance from 3.44 with the farmer all the way down to 3.15-ish for the second party here, similarly for the first adventure party. That seems significant. There's something about the way these tend to play out, and of course they have to be equal. These pairs for the symmetry rule, this number has to equal this number across the diagonal. But the fact that these don't have to be the same as these is pretty cool. It reveals something. I don't know what I would call that, but it's an interesting property that I noticed. This doesn't show you a whole lot. Like, it doesn't show you if one party is winning and the other party's losing. There's like, how often is it the whole party still up, or is like usually just one person up? It's a little hard to estimate from this because of the fact that these are pulling against each other, sort of like the times when this party wins against this party and has a couple people standing up decreases this mean, but the same exact thing can happen the other way around with the same probability to decrease this mean. So I don't know. There's a story there that is not entirely told, but there's a hint to its existence in that pattern. I'm not sure how useful this particular mode is overall. It is nice to be able to have another style of test. It does exercise and move around the API a little bit to be able to do something like creating this matrix and running all of those pairwise combinations. And both this and the analyze roads test are going through a table ASCII layout thing, by the way, which I don't think I've shown yet in any of these. So the table system has a few helper functions, where you can begin a table, you begin a row, you write down some cells, you can put format strings into it if you want, and then when you're done, you just take that table. It just has print right now. This could be like a stringize function or something, but all that ends up doing is it scans across the columns of each row and figures out the width of each column, and so it makes a table where it doesn't do the thing where, like, normally when you're doing printf tables and you have to like keep going in and like making the columns wider and wider so they have more and more space. This just figures out the correct width after the fact and then lays out the final ASCII. So it's able to make these matrices that are nicely packed. Like this. Right? Like that was just all automated in these things. That's what the table printing is for. So that's it for all the functionality in this project so far. I think in another video, I'm going to edit together everything I've done so far, and this is sort of the quick tour around the tools and things that I've been building. I think another thing to do that would be nice would be to introduce a little bit more in detail how the tile scripting and brain scripting is working. And so that'll be a kind of different topic that might take a video or two separately. All right, so you can look forward to that on this same project pretty soon after this comes out. Okay, bye-bye.